Welcome to Brain Vision.
For this question, we're asked to calculate the first three wavelengths for the Lyman series, where the wavelength equation is represented as 1 over lambda is equal to the Rydberg constant, R sub h, times 1 minus 1 over n squared. So for the Lyman series, n is equal to some integer value between 2 and infinity. So we're starting with n equals 2. So we just need to rearrange this equation to solve for lambda, and we can call this lambda value lambda 2. So it's just simply going to be equal to what's on the right side of the equation, all raised to the -1. To get lambda out of the denominator and into the numerator, we need to raise both sides to -1. So this is minus 1 over 2 squared, all raised to the -1. So plugging these values into this equation, carrying out this calculation, of course, the Rydberg constant here is equal to 1.097 times 10 to the 7. So carrying out this calculation, we find that the wavelength, when n is equal to 2, is equal to 121.5 times 10 to the -9 meters, or 121.5 nanometers. We can box it in as part of our solution for A. So we want to find the first three lines. So the next one would be when n is equal to 3. We could call this lambda 3. This is going to be equal to, we have the Rydberg constant multiplied by 1 minus 1 over 3 squared, which is 9. So you could just write it as 1 over 9, or you could write it as 1 over 3 squared. I'm going to write it as 1 over 9. And then all this gets raised to the -1, of course. So carrying out this calculation, we find that this wavelength is equal to 102.5 times 10 to the -9 meters, or 102.5 nanometers. And then the third one is n equals 4. We can call this one lambda 4. This is equal to, same equation, we have the Rydberg constant times 1 over n squared, except this time n is equal to 4, so this is times 1 minus 1 over 16. And all this gets raised to the -1. Carrying out this calculation, we find that this is equal to 97.2 times 10 to the -9 meters, or 97.2 nanometers. For part B, it says what part of the electromagnetic spectrum are these wavelengths? So to figure this out, I just looked up the electromagnetic spectrum wavelengths, and I found that these wavelengths all fall within the far ultraviolet region. So you can type out far ultraviolet region. We'll blow this up, make it a little bit bigger. We can box that in as our solution for part B.